didn't do it, we're going to record it, so if you do print these off later and just want to fill them in later, you can do that. Anyways, this unit is your 5th unit, and we have 3 more units left after this, and then you're done 30-2. So this, after we're done this unit, this is like the halfway mark at this very first day right now. So we're going to describe orally and in written form characteristics of polynomial functions. So linear, quadratic, cubics. We've done linear in grade 10, quadratics in grade 11. Someone let Quinn in. And we're doing cubics in grade 12. Describe orally and written form the characteristics of polynomial functions. We're going to match equations with graphs. We're going to graph data. We're going to graph equations. We're going to make regressions, all this stuff. But yeah. So today we're going to look at degree 1 and 0, 1, and 2. We've kind of looked at these before yesterday. If I were you, I wouldn't write down everything. Just pay attention for the most part if you didn't print them off, because you'll never have enough time. So the degree of this function is, the degree of a polynomial function is the highest exponent. So you've done this before. The degree of this exponent is what? Of this equation, sorry. 2, because it's the squared. The constant term is the term without a variable, right? Which is -5. Now remember I told you on Friday, if you were here, that if it's not in brackets, your constant gives you what? The constant is just the y-intercept. Yeah. So that's why we care about the constant. The degree tells us if the arms are both up or arms are both down, or one's up or one's down. Remember how we were doing that? So the degree of this function is degree 1, because it doesn't have an exponent, so the exponent will be 1. The constant term is -4. So we're just paying attention for this. And this one doesn't have a variable, but if I put a variable on it, I'd do x to the 0, so it's degree 0. And it is a constant function because it doesn't have a variable. Then we're going to look at this one. The leading coefficient. The leading coefficient is the number that multiplies the term with the highest power. The leading coefficient is basically the number that's in front of the largest exponent. Okay? So if this is x squared and doesn't have anything in front of it, it's not a 0 here, because if it was a 0, 0 times anything is 0. It would go away, right? It's not going to go away, or it wouldn't have been there in the first place. So it must be a 1. So the leading coefficient of this is a +1. The most important part about the leading coefficient is actually not the number itself, it's the sign. Because remember, the sign tells us how it ends on the right. Remember, we went over that on Friday? So the leading coefficient of this one would be 2, because the largest exponent is x1, and the leading coefficient is the one that leads it. It's the one that's in front. Now the rest of these have coefficients. Like this is a -4 coefficient of this x, right? It's just not the leading one. The leading coefficient is the one of the largest exponent because it leads the equation. So for these ones, in a polynomial function, all the coefficients must be real numbers and all the exponents must be whole numbers. So you can't have negative exponents. You can't have fraction exponents. You can't have square root exponents and stuff like that. But what I want you guys to try and do is write this. Degree 2, so write a polynomial function that satisfies the conditions. Degree 2, leading coefficient is -3. So if it's degree 2, my largest exponent is what? X squared. Leading coefficient of -3 means in front of the x squared, I have to have a -3. So I can have -3x squared. That would be enough to satisfy these conditions. Could I add extra stuff to the back of it? Yeah. I could go -7x + 4. Or I could have just left it as -3x squared. Or I could have went -3x squared minus 7x and not put the +4. Or I could have went -3x squared + 4 and it would still have satisfied it, right? Minimally, I just needed to have the -3x squared to follow those conditions. I want you guys to try the next 4 bullets, see if you can do it. So the second bullet says degree 2, leading coefficient 7. So I know I'm going to have a 7x squared. And then I need to add another term. I can't add anything with an x greater than x squared, right? Or else it would be degree 3 or degree 4 or degree 5. That's my only limitations. So I could add something with an x, or I could add just a constant at the back, right? Just a number. It doesn't matter, but I can only have 2 terms. So I'm going to add a +12. If you like added a 2x, and that's it, that's just fine. Terms are separated by plus or minus signs. So this one here has 1, 2 terms. This one here has 1, 2, 3 terms, okay? The third bullet says degree 1, leading coefficient of 1. So I literally could just go like this, 1x, and be done, right? because it's covering all of the conditions it tells me. But I could put a -2 at the back and still be correct. Could I put a like positive 2x squared at the back and be correct? No, because then it's a degree 2, right? Degree 0 means it's a constant. So like f of x equals -2 or 7 or 5 or 3 or 8. Okay? Because when it's a constant like that, I could put x to the 0 behind it, but you would never see x to the 0. They're not going to write it like that. And then degree 3 constant term 8, I could go 2x cubed, or I could just go x cubed. I wouldn't have to put a number in front of it at all. It doesn't tell me I have a leading coefficient of any number, so I can put whatever I want. And a constant term of -8, so I can just go -8 at the back. Or I could have written 1x cubed plus 3x squared minus 4x minus 8. As long as I have the x cubed and the -8 at the back, I'm correct. I could have only put 3 terms instead of 4, right? Okay, we're going to look at degree 0 first here. Like I said, if you're going to print the notes off later, you might want to fill them in later. If you're not going to print them off, you're going to have to write some stuff down. So degree 0 means x to the 0, which means it's a constant. So put y equals 2 in your calculator. Go into the y equals, press zoom 6, so you clear it off. Zoom 6 sets your window back to standard, that -10, 10, 10, 10. And put y equals 2 in your calculator. Press graph. Okay. Now go into your y2 and put in y equals -5. Now, watch this. So, I went zoom 6, and then that sets it back to the 10, 10 window, right? Without you having to do it, which is really nice. This one has a X4 in it because it's from grade 12, like 30-1. But anyways, I told you to put 2 into your y1, and into your y2, I said put -5. Now, if you have a colored calculator that pulls up a colored screen on it, please, everyone with a phone out needs to put it away because you're learning steps on a calculator and you're not. You'll have colored different images, right? So you can see colored. A lot of people don't have that option, though. So the way I say that you can do it so that you can see the difference at least between 2 different graphs is if you arrow over here onto that blinking line, and you hit enter once, it'll make it thicker. So at least you'll know that and I always make the second graph thicker so that I always know that the second equation I put in is the thicker graph. I just always do it so it's consistent. But when you press graph, so on your first graph, the first equation drawn, some people will say, well, the first equation drawn is the first equation, which is true. The first equation drawn is the first equation. But now I'm talking to you and I look back and I'm like, oh no, which one was drawn first, right? Then I forget. This way I know, oh, this one was drawn first, this was drawn second because it's the thicker graph. So, so on here I'm going to, and then it wants us to graph f of 3. So f of 2 was the one that we drew. It was at y equals 2, right? So this would be f of x equals 2. And I told you to do -5. So 1, 2, 3, 4, 5. This would be f of x equals -5. It also told us to draw 3. So where's 3 going to be? At 3. Just a horizontal line through 3. Okay? So what's the domain and range of every single one of those lines? What's the domain of those lines? X is an element of all the real numbers. Because if your arrows can go out to the right and left forever and they're never like, the only time X isn't going to be an element of the real numbers is if the graph like curves back on itself or something, right? And then it'll never come over here, or it curves back on itself this way and it never comes over here, right? Or you have asymptotes and it cuts through it or something like that. Well, this graph keeps going to the left and right everywhere. So So the domain of this one is going to be x is an element of the reals. So x such that x is an element of the reals is my domain. What's my range of f of x equals 3 of this graph when y equals 3? Range is the y values. What's the only value on the equation y equals 3? 3. Y equals 3. That's the only one. So on these constant functions, the range is actually whatever the heck your equation is, right? So the range for this f of x function of 3 is going to be y such that y equals 3. That's it. Y equals 3. Now we want to write two other functions with degree 0. We already did. We have f of x equals 2, and we have f of x equals -5. Right? What changes with domain and range on those if I change the equation? Does the domain change? No, they're still going out forever. The domain doesn't change. But my range becomes y equals 2 for this one, and y equals -5 for that one, right? Because that's the only values that exist. So only the range changes. Y equals 2, and y equals -5. Sketch them and labeled them. We already did. Describe the general shape of each graph. It's a horizontal line, right? That's all they are. They're just horizontal lines. State the number of y-intercepts. How many times do each of these cross the y-axis? Once, at the value they are, right? So there's one y-intercept. Do any of these graphs have an x-intercept? If so, state the function. If not, can you determine a polynomial function of degree 0 that does have an x-intercept? So do any of the ones we drew cross the x-axis? No. They're either above the x-axis completely or below the x-axis. Can we draw any that would cross the x-axis? Would there be any line, horizontal line we could draw that would cross the x-axis? The one that's on the x-axis at 0. So if I drew, please pretend that's actually on the x-axis. If I drew f of x equals 0, f of x equals 0, it would be on the x-axis, and how many x-intercepts would I have? All of them, an infinite amount, right? Every single spot on the x-axis would be counted. So I have an infinite number of x-intercepts. Describe the relationship between the equation of each function and the range of each function. What can you say? The equation is the range. So if it's like the equation is f of x equals 3, the range is y equals 3, right? If the equation is f of x equals 0, then the range would be y equals 0. So the equation is the range. So we're going to sum it up. Generalize the above work, or the previous page, I guess, to complete the following statements for all the functions of degree 0 in the form f of x equals c, where c is a number, like 1 or 2 or 3 or 4. The graph is of what line? What kind of lines were all of those? Linear, okay. More so specifically? They're straight. More so specifically? Horizontal. Graph is a horizontal line. Horizontal line with slope of what? It's like slope of Saskatchewan. It's very flat. What's that slope? 0. The domain is always what? XER. Remember, you're going to need some notes because for your hand and you can look at your notes, but no one else, right? That's all you get is your notes or your brain. Your brain you can bring with as well. The range is, for this one, y such that y equals c. That's an equal sign. It doesn't look like it. Oh, that's getting worse. And I said c because for this function, they just are using a c instead of a number. So if it was f of x equals 7, then it'd be y equals 7. If it was f of x equals -1, then it'd be y equals -1, right? So you just put in whatever the heck c is. There are how many x intercepts except for the function f of x equals what? Those first three we drew, how many x intercepts were there? None. There were no x intercepts. They didn't cross the x-axis at all. Except for the function f of x equals 0, where it had infinite x intercepts. How many y-intercepts were there for each graph? Horizontal, cuts to the y-axis. Horizontal, cuts to the y-axis. Horizontal, cuts to the y-axis. How many did they each have? How many y-intercepts? 1. There is a, it should be there is 1. There shouldn't be an a. There's 1 y-intercept. Does the value of the polynomial function of degree 0 depend on the value of x? No, there is no x, right? The constant. Since the values of the polynomial function of degree 0 remain constant for all values of x, this function is called a constant function. You've dealt with constant functions before, but we just didn't look at them in big detail. We're just showing you them just so you can see them, but for the most part, we just deal with linear, quadratic, and cubic. So we go to degree 1 functions like we did in grade 10. And you kind of looked at them in grade 11 too. The graphs of 4 polynomial functions degree 1 are shown. The graphs shown have many characteristics in common. Make a list of the characteristics in common in the space below. What's in common? What do all these graphs have in common? So they're linear straight lines. What else do they have in common? Think about domain, range, x-intercepts, y-intercepts. They're continuous, which means what? What about the domain? The domain of every linear function is x and element of reals. Because the arrows are going outwards. The arrows are also going up and down forever. So what's their range? Linear and cubic functions, unless their word problems, are fantastic because their domain and range is XER, YER. Because they have arrows going up and down and arrows going out in both directions, right? So that means every x value exists on them and every y, unless it's a word problem. How many y-intercepts do they all have? How many times does each line cross the y-axis? Once. So they each have 1 y-intercept. What about x-intercepts? How many do they have? How many times does each one of them cross the y or the x-axis? Once. We did this, looked at this Friday. How does the constant term in the polynomial function relate to the characteristics of the graph? That constant term, the constant term is the one that remains constant, doesn't have an x value. The y-intercept. So the constant term is the y-intercept. But remember, these equations can't have brackets. If the equations have brackets in them, like if it was like to bracket x plus 3 plus 7 or something like that, your plus 7 at the back would not be your constant of the function. You'd have to distribute into the brackets first and then look at your constant. So your equation can't have brackets in it in order to look at the constant and say it's the y-intercept. See, this one has a -4, it crosses at -4. This one is a -4 because it crosses the y-axis as -4. This one has a plus 0, so it crosses the y-axis at 0. This one is a plus 2, so it crosses the y-axis at +2. Yeah? Great thing about polynomials is that happens for degree 2 and degree 3 as well, as long as there's in brackets. All right. How can you tell for the equation of the polynomial function whether the line increases from quadrant 3 to 1? So remember, quadrants go like this, 1, 2, 3, 4. So it's asking increases from quadrants 3 to 1, so ends on the right, positive, or decreases from quadrants 2 to 4, so ends on the right, negative. Do you remember what I said on Friday? Yes, if what's positive or negative. Right. So if they have a positive leading coefficient, so this is a positive 3x, that doesn't look like a positive, and this is a positive 2x, they end up on the right. These ones have negative leading coefficients, so they ended down on the right. Okay? So positive leading coefficients equals, means up on the right. Negative leading coefficient equals down on the right. And linear lines, we know that the arrows are always in opposite directions. So if it ended up on the right, it's going to end down on the left, correct? And if it ends down on the right, it's going to end up on the left, because linear lines are always in opposite directions. If they wanted to go in the same direction, the arrows, it would no longer be linear. You'd have to curve the line at some point. The polynomial functions g of x and h of x are represented graphically by parallel lines. How can we tell from the equations that this is the case? So g and h are parallel lines. Why? What's up with their equations that they're parallel? Same slope. This one's -1/2, this one's -1/2. They just cross the y-axis in different spots. So y equals mx plus b. Yeah. So m, which is the slope, slopes are the same. Okay. So we're going to do a summary of linear functions. Remember, this should all be a review to you because this is all from grade 10. Review from a long time, so your brain probably doesn't remember it. But generalize the above work to complete the following. So you're going to tell me the shape of, polynomial functions of degree 1 in the form f of x equals mx plus b. The shape of the graph is a what? Smiley face? What were the shapes of the graphs we just looked at? Straight line. With a slope of what? M. What's the domain of every linear function? The domain of every linear function, unless it's a word problem. X and M of the reals. What's the domain of every polynomial? Degree 1, degree 2, degree 3, and constant functions if it's not a word problem. XER. Every single time. Unless it's a word problem, then it might not be X and M of the reals because it could involve time, and you can't have negative time or something like that. So the domain is XER. What's the range of this linear equation if it's not a word problem? What's the range always? Same thing. Y is now of the reals because you have arrows going up and down. There is one x-intercept and one y-intercept. The y-intercept is what of f of x equals mx plus b? B. The direction of the line is determined by the value of the leading coefficient. If the leading coefficient is what? The line slopes from quadrants 3 to 1. Positive. And if the leading coefficient is what? The line slopes from 2 to 4. Negative. Since the graph of a polynomial function of degree 1 is a straight line, then this type of function is called a linear function. Okay, we're going to look at degree 2. Degree 2, whether you were in 20-1 or 20-2, you looked into big depth. Okay? Polynomial functions of degree 2, not TO, 2, TWO, are called quadratic functions and were studied last year. The graphs of 4 polynomial functions of degree 2 are shown. So you have both versions. You have the equations without brackets and the equations with brackets. From the list of characteristics below, circle the ones that are the same for all graphs. Are their domains the same? Not you. Okay. So are the domains the same or not? You have arrows going like this. So they're going out in every direction to the right and to the left. So the domain is XER. So yes, the domains are the same. Are the range of quadratics the same? No. This would be y is less than or equal to 0. This would be y is greater than or equal to -8. This would be y is greater than or equal to 10. This would be y is less than or equal to 18, it looks like. So the ranges are not the same. The number of X intercepts, the way they cross the x-axis, is it the same? This one never crosses the x-axis, so it has no X intercepts. This one has one X intercept, it just happens to be the same spot, right? And this one has 2. This one has 2. Do they have the same number of X intercepts? No. Number of Y intercepts, do they have the same number? This one crosses the y-axis here. This one crosses the y-axis here. This one crosses the y-axis here. So yes, they all have one y-intercept. And all polynomials are going to have one y-intercept because they don't cross back like this over top of the y-axis, right? Because then they wouldn't be a function. Also, look at our back number. 10, 10, -5, -5, 10, 10, -8, -8. However, if I take the bracketed form, it doesn't help me for y-intercepts, right? It helps me for x-intercepts. Yeah. How does the y-intercept of each graph relate to the equation? The constant value at the back? The constant value, one without a variable. Is the y-intercept. Remember, though, the equation can't have brackets, though, right? So it's the same thing every single time, that constant. It's not here. Okay, the graphs are all parabolas opening up or down. How can you tell if they open up or they open down? The leading coefficients. If you have a positive leading coefficient, it's going to be up on the right, correct? If it's up on the right, it's also going to be up on the left, because quadratics open in the same direction with both arms, right? Even function open with the same arm. So if it's a positive leading coefficient, it's going to open up. If it's a negative leading coefficient, it's going to be down on the right, which means it's going to be down on the left, so it opens down. How can you tell from the equation of the polynomial function whether it's a max or a min? So the leading coefficient caused me to have this, right? Because it was up on the right. Is this the minimum value or the maximum value of this graph? Minimum. It's the lowest you can go, right? Or higher. So if you have a positive leading coefficient, you also have a minimum. And if you have a negative leading coefficient, it's down on the right. And you have a hill, so you have a maximum. If you can't remember if they're minimums or maximum, pretend it's a person walking on it. So we have a person, he's walking down the hill, and he's walking down the hill, and he gets to here. Did he get to the minimum or the maximum? He got to the minimum. He's a little dude, and he got to the minimum. Unless he's got a shovel, he's not going any lower. And then if we have this graph, and we have dude, and he's walking along it, whoa, this is getting worse. He's just, yep, he's there. And he get, yep. It won't draw where I'm drawing it. That's okay. He's up here, unless someone is willing to like this, and they can step on him. He's at the maximum. He's not getting any higher unless he's got a ladder. Well, I don't know why he took a ladder up there, but either way, he still can only get to the maximum. He can't get to the minimum. The range is to be written in that form, okay? So what we're going to do is I'm going to give you an equation, and you're going to find the maximum or minimum value of it. Because unless you find the maximum or the minimum value of the equation, you can't give me the range. All right? So say I give you this graph, y equals negative 2x squared plus 3x minus 4. Is that graph up or down? Down, because I have a negative leading coefficient, which means it's down on the right, which means it's down on the left. Correct? So do I have a maximum or minimum with this equation? Maximum. Okay? Range for these ones where they open down, the range is going to be y such that y is less than or equal to that maximum value, right? YER. What's my issue right now? I have no clue what that maximum value is, correct? But your calculator, this wonderful thing that you paid lots of money for, can find it for you. So you might as well use the actual calculator and get your money's worth. So go into your calculator and type in your equation. So you're going to go y equals and clear out everything else you have in it. And you're going to go negative 2x squared plus 3x minus 4. Please, the only reason why people, well, one of the main reasons why people get these equations wrong in their calculator is they put them in not the way they say them. So they put subtraction sign 2x squared. Do you say subtraction sign 2x squared? No, that sounds ridiculous. You say negative 2x squared. So you have to press the negative button. And then you say plus 3x, bless you, and then you say minus 4. You don't say negative 4, right? So if you put in negative sign here instead of a subtraction sign, or a subtraction sign here instead of a negative sign, it's not going to be the same graph. It just won't. Okay? So let's press graph once you have that in. I'm trying to calculate something. What am I trying to calculate? The maximum. Okay? I'm trying to calculate a maximum. Is there anywhere on your calculator that has calculate? Because we're trying to calculate a maximum. Second, trace. Because the little word behind trace is calc. You really can't see it, but it says calc on your calculator. Okay? So you're going to go second, trace. Because that means you're getting the yellow word behind it, which is calc. What button do you think we'd push if we were trying to find a maximum? Not minimum. That's just silliness. Not 2, because that's a 0. We would pick maximum. Very easy to find if you know that that is a maximum. If you're trying to find a minimum of a maximum, it's going to error you because you're trying to find something that doesn't exist. So it says left bound now, guys. It says left bound. What am I going to do? Go on the left side of whatever I'm trying to find. Go on the left side of whatever I'm trying to find. So I'm trying to find the maximum. I need to be on the left of it. I am on the left of it, so I hit enter. Then it says right bound, so I need to be on the right side of it somewhere. Hit enter. And then hit enter again when it says guess. So it's at 0.749983. So do I put that there? That's the x value where it happens. What's the actual maximum value? It's always the y, right? That's the maximum height. I'm giving you the range based on the y. So it's negative 2.875. So I'm going to go y such that y is less than or equal to negative 2.875 YER. So what did I do to find this? I went second, trace, which is calc, number 5, which is maximum. And then you just follow the instructions after that. Left bound, go on the left. Right bound, go on the right. And then enter. Okay, I want you guys to try this one. Y equals 3x squared plus 2x minus 3. Give me the range of that one. All right. So we go to our calculator. Go to your calculator, go to your y equals, clear it out. Please do not make me be the person who's solving these for you, because if you don't touch your calculator in this unit and you do not learn all the steps in this unit, your mark will be terrible, because there are lots of calculator steps. So we always have to do them. You can't just follow along with me watching. It will never embed in your brain and you will not get these on your test. So 3x squared plus 2x minus 3 or negative 3. How do I say it? Minus 3. So I type it in as minus 3. Press graph. Second, trace, minimum, is 3. Maximum is 4, isn't it? I think I put the wrong number. Good one. All right. Left bound. So I need to be on the left of it. Some people are on the right and hit enter, and then on the left, and they show me, and they're like, it just doesn't work. And I'm like, which hand do you write with if you're right-handed? Then if you're left. Right bound. And we take the negative 3.3 version. So we're going to say range y such that y is what this time? Greater than or less than that value? Is the graph all above that value or all below that value? All above, so it's greater. So it's greater than or equal to negative 3.3 YER. All right. Now, this one here, I want you to tell me how many X intercepts there are. We're not actually calculating X intercepts today. We're just going to look at them. These ones want you to tell, they want me to tell you what they are, but I don't actually want that. I just want you to tell me if there's 0 X intercepts, 1 or 2. Because with quadratics, you could have no X intercepts, where the graph is completely above, or the graph is completely below. Or you could have 1 X intercept, where it runs tangent to the X axis. Or it can be down like this and run tangent. Or you could have 2 X intercepts, where it just goes through. Right? So your options for linear was there was 1 X intercept no matter what, right? Your arrows are going in opposite directions. It's going to have to cross somewhere on the X axis. But with quadratics, the whole thing could be above or below. So you could have actually no X intercepts, or 1 or 2. You have options with quadratics. So let's look at this first one here. A. We're going to plug it in our calculator. It's the easiest way to tell how many X intercepts there are. Look at it. Your calculator lets you punch it in. Punch it in. Get your money's worth for your calculator. X squared minus 4x plus 5. Graph. How many X intercepts? I type it in wrong. This is not factored right at all. Okay, it has 0 X intercepts at nowhere because there aren't any. Then the next one, is it down or up? It's down. What's the y-intercept? 10. Okay. Negative 2x squared plus 8x plus 10. There's a good chance that this graph is going to have an x-intercept. Think about it. Its y-intercept is at positive 10, and the graph goes down. Right? So there's 2. Oops. 2. I don't care where they're at this point right now. Then we'll put in the other one. Negative 2x squared plus 8x minus 8. So what I want to do is see if it crosses in one spot or if it crosses in a couple. So we're going to check it out. So I'm going to go to my window, and I'm going to reduce my y's so that my screen is bigger, right? Closer to that x-axis. So I'm going to make my y min be negative 1 and my y max be 1. Make my scale go up by 0.25. It doesn't matter if you left it here at 1. It wouldn't change it. Oh, that was a very bad guess. Okay. We'll make this be 1. Make this be 4. So I can see the rest of the graph. What do I have? What do I have? 1. This is factored totally out to lunch again. Okay. Sometimes it looks like there's 1, but it actually, like when you zoom in, it'll go up past it and back down. You're like, oh, there was 2. Okay. So I'm going to give you the homework for today and tomorrow, but you're going to get to work on it at the beginning of class tomorrow too. But it's out of the workbook. We use workbook and textbook. You might want to, well, you're either going to have homework today or tomorrow, because if you don't work, if you work in class tomorrow really, really well, you'll finish it in class and have no homework.